Our universe wasn't always here. It had a mysterious and intriguing beginning. It had a beginning just like everything else, a moment when everything we know came into existence. Imagine a time when there was nothing, no stars, no planets, not even space itself, just an infinite void, silent and empty. Then, about 13.8 billion years ago, everything changed. In an instant, the universe as we know it began. A massive explosion, which we call the Big Bang, happened. This wasn't just any explosion, it was the birth of everything. This explosion wasn't like a fireworks show. Instead, it was the rapid expansion of space itself. Space stretched and grew at an unimaginable rate. Think of a tiny dot suddenly inflating to become something incredibly vast. That's the Big Bang. From a minuscule point, the universe expanded to an immense size. As the universe expanded, it cooled down. The intense heat of the initial explosion began to dissipate. Tiny particles, like the building blocks of atoms, started to form. These particles were the seeds of everything that would come later. These particles eventually clumped together to form the first stars and galaxies. The universe was beginning to take shape, filled with light and energy. It was a time of incredible energy and change. The universe was a dynamic and ever-evolving place, but tucked away in one corner of this young universe, a cloud of dust and gas was about to have its own story to tell, the story of our Earth. This cloud would eventually coalesce to form our solar system, giving birth to our planet. In a quiet corner of the Milky Way galaxy, far from the bustling center of our cosmic neighborhood, a giant cloud of dust and gas drifted through space. This cloud, known as a nebula, was a vast and diffuse collection of particles stretching across light years. This cloud was mostly hydrogen and helium, the simplest elements in the universe. These elements are the building blocks of stars and planets, but it also contained tiny bits of other elements like oxygen, carbon and iron. These elements, though present in smaller quantities, play crucial roles in the formation of celestial bodies. These heavier elements were the leftover ashes from stars that had lived and died long ago. When massive stars end their lives in spectacular supernova explosions, they scatter these elements across the cosmos. Gravity, the force that makes things fall down here on Earth, was at work in this cloud of dust and gas. Gravity pulls everything together, from the smallest particles to the largest galaxies. Over millions of years, gravity drew the dust and gas closer and closer. This gradual process of accumulation is how stars and planets begin to form. The cloud began to spin slowly at first, then faster and faster. This rotation is a natural consequence of the conservation of angular momentum. As the cloud spun, it flattened out into a giant disk. This disk, known as a protoplanetary disk, is where planets, moons, and other celestial bodies start to take shape. At the center of the disk, the material became incredibly hot and dense. This central region, called a protostar, is the birthplace of a new star. The pressure and heat became so intense that hydrogen atoms began to fuse together, releasing enormous amounts of energy. This process, known as nuclear fusion, marks the birth of a star. Our sun was born. While the sun blazed at the center of the disk, its immense gravity held everything in place, creating a gravitational dance that would shape the future of our solar system. The leftover dust and gas continued to swirl around it, forming a vast, rotating disk of material. This disk was a chaotic mix of particles, each one playing a crucial role in the birth of planets. These tiny particles collided with each other, sticking together through static electricity and other forces. Over time, these clumps grew larger and larger, forming planetesimals, the building blocks of planets. One of these planets, about 93 million miles from the Sun, was our Earth. It started as a small rocky body, gradually accumulating more material through countless collisions. In its infancy, Earth was nothing like the planet we know today. It was a hostile environment, a far cry from the blue and green oasis we now call home. Instead of a solid surface, it was a fiery ball of molten rock and metal, constantly churning and reshaping itself. The heat from its formation and the energy from constant impacts kept it in a molten state. The early Earth was constantly bombarded by asteroids and comets, adding to its mass and heat. These impacts brought not only destruction but also essential ingredients for the future. Volcanoes erupted across the surface, spewing lava and gases into the atmosphere. These eruptions released water vapor, carbon dioxide, and other gases, gradually forming a primitive atmosphere. Imagine a world covered in fiery oceans of molten rock that was Earth in its early days. These molten oceans were in constant motion, driven by the planet's internal heat. But even in this chaotic environment, the seeds of something amazing were being sown. The building blocks of life were being delivered by comets and asteroids, setting the stage for the future. The building blocks of our planet were coming together, piece by piece. Each collision, each eruption, was a step towards the creation of a world capable of supporting life. As Earth gradually cooled, something incredible happened. The water vapor in the atmosphere condensed, forming clouds. Then rain began to fall relentlessly for thousands of years. The rain filled the low-lying areas, creating the first oceans. Meanwhile, volcanoes continued to erupt, releasing gases from the Earth's interior. These gases, including nitrogen, carbon dioxide, and water vapor, formed Earth's early atmosphere. This early atmosphere was very different from the air we breathe today. It was much thicker and contained almost no oxygen. But even this early atmosphere played a crucial role in Earth's story. It helped to trap some of the sun's heat, keeping the planet warm enough for liquid water to exist. This was a critical step towards making Earth suitable for life. Section 5. A planet transformed from fire to life's first spark. Over millions of years, Earth continued to cool and change. The bombardment of asteroids and comets slowed down. Volcanic activity decreased, although it never stopped entirely. The Earth's crust, the outermost layer of our planet, solidified and broke into giant plates that moved and shifted, a process called plate tectonics. These movements of the Earth's crust created mountains, valleys, and ocean basins. The continents, once joined together, slowly drifted apart, forming the familiar shapes we see on maps today. The early oceans, once hot and acidic, gradually became cooler and less harsh. The stage was set for life to emerge. But how did life actually begin on our planet? Section 6 and the Blue Marble, an oasis in the vastness of space. Billions of years ago, in the shallow waters of Earth's early oceans, something extraordinary happened. Simple, single-celled organisms, the first forms of life, emerged. These early life forms were tiny and simple, but they had a remarkable ability. They could reproduce and pass on their traits to their offspring. Over countless generations, life on Earth evolved and diversified. Organisms became more complex, developing new ways to obtain energy and adapt to their environments. Photosynthesis evolved, allowing some organisms to harness the sun's energy and release oxygen as a byproduct. The oxygen released by these early photosynthesizers gradually accumulated in the atmosphere. This was a turning point in Earth's history. Oxygen, once a toxic gas, became a vital component of the air we breathe. Section 7. Life finds a foothold, the early days of a living planet. With the rise of oxygen, life on Earth exploded in diversity. The first multicellular organisms appeared, followed by an incredible array of plants and animals. The oceans teemed with strange and wonderful creatures. Plants colonized the land, creating vast forests. Life on Earth has faced many challenges over billions of years. Giant asteroid impacts, massive volcanic eruptions, and dramatic climate shifts have all threatened life's survival. But each time, life has found a way to adapt and endure. The story of life on Earth is a testament to the power of adaptation and the interconnectedness of all living things. From those first single-celled organisms to the incredible diversity of life today, Earth's biosphere is a remarkable and precious phenomenon. Section 8. Our home Earth, a story billions of years in the making. The Earth we know today, with its continents, oceans, atmosphere, and teeming life, is the result of billions of years of cosmic and geological processes. From the violence of the early solar system to the slow, steady hand of evolution, our planet has been shaped and reshaped into a unique and precious world. As we look out at the night sky, we are reminded of our place in the vastness of the universe. Earth is a tiny oasis of life in the cold, dark void of space. It is our only home, and it is up to us to protect and preserve it for future generations. Section 9. Looking back to understand the present and future. Understanding how Earth formed helps us appreciate the delicate balance that makes life possible. It reminds us that our planet is not static, but constantly changing. The forces that shaped Earth billions of years ago are still at work today, influencing our climate, our geology, and even our own evolution. As we continue to explore the universe and search for life beyond Earth, our understanding of our own planet's history will guide us. By studying the past, we gain insights into the present and the future of Earth, the only home we've ever known.